question 4. Anybody needs help for any question in question 4? Raise our hand right now. Okay, which part? 4C. Any more? Any more besides 4C? Okay, then we'll just do 4C, yeah? Okay, let's try and find out some of the unknowns first. How many triangles do you see in this diagram? Hey, trick question. How many triangles do you see? 3. Okay, because sometimes we really may require the big triangle to help us solve it. Alright, so as of yesterday, we've only done our tangent, sine, and cosine for right angle triangles. We haven't learned anything else yet. So here, as long as we have, okay, so sine, cosine, and tangent, these are trigo ratios. Whether it is sine, cosine, tangent, they will be of this form. Sine theta, cosine theta, tangent theta equals to something over something. Okay, so tangent opposite over adjacent. Sine will be opposite over hypotenuse. And this will be adjacent over hypotenuse. So these are for right angle triangles. What this means is that as long as I have one angle plus one side, one angle plus one side, I can find everything else. Okay? If I have two sides, I also can find everything else because it is a right angle triangle. Okay, this angle over here is not including the 90 degrees. Okay, so all of these 3 triangles that you see in this question, is that a triangle that provided you with this information? One angle and one side. Roshini, can you see that? Is that a triangle that has one angle and one side given? Which one is that? What is the triangle? PRQ. Let me highlight that out. PRQ. So based on this, which trigo ratio will you use? Tangent? Okay, let's start with tangent. Tangent 37 degrees, because that's the only angle I have. We don't consider the 90 degrees because it doesn't help us. Where got chess at the back? What's the meaning of the chessboard? Tangent 37 degrees. Okay, so opposite. What is the opposite side, Roshini? X. Okay, then the adjacent, Zachary. 12. Excellent. So x equals to 12. Tangent 37 degrees. Okay, so okay, that's not the answer yet. You punch it into your calculator, round it off to 3SF. That's for x. Yes. In the? Does the bracket matter? No. Okay, you're asking because when you key in tangent, they automatically give you a bracket, right? Cos what? What do you mean I put a degree? So 12 tangent 37. If you are using a Casio, whether you close bracket, you don't close bracket, you'll still get a correct answer. I don't have an answer for that. It is the calculator designer. Okay, so here we have 9.042. So rounding off 3SF, 9.04. So that's our length x in cm. Next is to find theta and y. Okay, so this 9.0426. With this, I have one more triangle to consider. Okay, this triangle over here. I have one side, two sides. So like I said, if you have two sides, you can solve for everything else already using one of the trigo ratio. Which one do you think you should use? Cosine? Shall we use cosine? Okay, let's try cosine. So cosine theta equals to adjacent 9.0426 divided by 11.5. So theta equals to cosine inverse 9.0426 over 11.5. Get the answer, round it off, right? Okay, so what is the answer over here? 38.157. 38.2. Okay, 38.2 degrees. Is this the correct answer? Okay. So here we have theta already. Then how to find y? Pythagoras theorem. Do I need the value of theta to find y? No need, huh? But can we use the value of theta to find y? Can or cannot? Can. We can use theta to find y. However, is there a better way? Is there a preferred option whether we use Pythagoras or theta? Why? Why would Pythagoras be preferred? Easier? More accurate? Easier is subjective. Why do you say it is more accurate? Okay, so he is referring to rounding errors. The more you round off, the further your answer gets. Am I right? As far as possible, we use numbers that are exact. Therefore, if you want to use the theta to find y, you can. But use this number over here that is not 38.2. I use the non-rounded off value. Use this one to find. Okay, as far as possible, go for the more exact ones. Okay, so that's the end of question 4. The next question we had is 7. Does anybody need help for 7? 1, 2, 3. Okay, let's do question 7. Okay, I'll be honest with you. I took some time to figure this out also. But it was doable. So this is D, 9, 8, 40 degrees, 25 degrees, A, B, and C. Okay. So we are able to use what we have learned, our trigo ratio for right angle triangles, right? In this case, how many right angle triangles do you see? Only one. You're supposed to find AB. Yeah, there's only one right angle triangle. Do you know any angles in this right angle triangle? I assume you are referring to this one. Do you know any angle inside this right angle triangle? Besides the 90 degrees, obviously. Don't know, right? Okay, do you know any other sides? Also don't know. Then how to use our trigo ratio? Because I said that we require 2 sides or 1 side plus 1 angle. So all don't have. What degree? But 25 and 40 are not the angles of this triangle. They are parts of angles of this triangle, right? So what if I do a dotted line over here? Okay, this I draw a rectangle. So in this case, I've got 90 degrees already. Do you think this helps? Yes. Okay, with these dotted lines, are you able to find, let's call this part point X. Are you able to find AX? Yes. How? Okay, which triangle do we use to find AX? ADX, yes. So ADX, sine 25 degrees equals to dx over 9. Is this helpful to me to find AX? But AX over 9 is not sine. It is cosine. So you see, in this case, you chose sine. Then you get dx over 9. That is not helpful to us to solve AX, to find AX. So what you should have been using is cosine to have our adjacent, which is AX, over 9. In this case, I have AX equals to 9 cosine 25 degrees. Now I want you to think about it. Cosine 25 degrees. What does that give us? Is it an unknown or a number? Cosine 25. All press calculator now. Cosine 25. Where's your calculator? Press the calculator and see for yourself that it is simply a number. Okay? So after that, we have to take the number multiplied by 9, right? Can you imagine? Okay, is it advisable, is it recommended to write down 9 times, what is your cosine 25? 0.906307. Should we do this? And then we do our times 9 equals to 8.15677. Then you round it off. Should we do this? No. What then should we do? Okay, do you want this step? The one. Do you want this step? The one. Should we leave it like this? Yes, we should leave it like this. This is the most accurate because 9 cosine 25 degrees, I don't want to evaluate. I know that this is going to be a number. I will use it at my final step. I don't want to go and evaluate and have so many numbers and then round off and round off. This is important for trigonometry. Okay? Don't round off unnecessarily. If you have the exact one, leave it first. So, from here we have AX already, but the question wanted AB. So now we need to find XB, which is quite clearly the same over here, right? From this part, AX plus XB will give us AB. So how do we find this this XB over here? Okay, Kevin, what do you say? Use sine, right? Sine what? 40 degrees equals to? BX over 8. Okay, correct. So BX, XB, they are same, so same over here. Some of you wanted to call this point Y, for example. Sure, you can do that, but no point lah, you already have it. Okay, so here we have XB equals to 8 sine 40 degrees. So therefore, AB must be equals to AX plus XB. So 9 cosine 25 degrees plus 8 sine 40 degrees. Only at this step, then I will use my calculator. But you must key in properly. Wherever brackets are needed, you put them in. Okay? So you will not lose your accuracy. So let's do it together. 9 cosine 25. 8 sine 40. We have 13.299. Okay, so 3SF. So round it off to become 13.3 cm. Okay, so I haven't read the remaining questions. Suppose the next few parts require you to use the value of AB. What will you key into your calculator? What will you substitute for AB? You have option number 1, option number 2, option number 3. Anybody use option number 1? Better not. Number 1 is almost guaranteed you will arrive at the wrong answer because it is already rounded off. Option number 2 is okay. Generally safe. I say generally only. Option number 3 is for very kiasu people like me. I want the very exact number. I will use 3. When you round off, 2 and 3 should be close. I cannot guarantee that they will be very close when you round off to 3SF. Could and should be the same, but there are times it is different. So I'm telling you, option number 2 is okay. Option number 3 will be the very kiasu one. It's the best. Okay. Okay. So Darius, you did it yourself at the back, right? Okay, Darius did it himself, and that is why he did not manage to hear me say that we should not evaluate. We should not evaluate this and add them up, which is what he did because he was at the back.
I did this. I did that because I found all the spotters.
Yeah. Okay, so don't round off the intermediate answers. So with this, you should be able to find BC because the approach is the same. Okay, find this part first, then you find this part. Alright? So finally, for angle CAD. CAD. Okay, this is now the unknown that we have in the question. So I'll take it that part B is done for you guys. Can I have the answer for the length of BC? 9.9319. Okay, very kiasu people. Now I want to find this unknown angle. How? I have two sides. What are the two sides? AB and BC. Okay, what was the AB just now? The very kiasu answer? 13.299. Okay, with these two sides plus a right angle triangle, I can find which angle? CAB. Yeah, I can find this large angle, right? Then after that, minus 25, I get the unknown angle already. So what is the trigo ratio I should be using to find CAB? Tangent CAB equals to 9.9319 divided by 13.299. Like I said, these 5 SF, they are okay. They are okay for your intermediate steps. But if you are kiasu like me, right, you will end up having writing, what was it? 9 cosine 25 degrees plus whatever, then, you know, okay? Okay, so regardless, you have a number over here. So your CAB will just be tangent inverse of the number. Then the unknown angle CAD is just CAB minus 25. That's it. Okay? Now question 13. Find the height of the helicopter. So we have P, this is 28 degrees. It is very important that you identify all the right angles. Okay, find the height of the helicopter above the ground. So over here, let's call this H. Let the height above ground be H. So how many right angle triangles do you see? Two confirmed right angle triangles. I do not know whether this is a 90 degrees or not, so I cannot confirm. So better not write it.
180 minus 42.
Oh yeah, Darius is right. We can actually tell, and it is how much? 110 degrees. Is that useful for us? I'm not sure. Okay. So now we see the two right angle triangles. As always, we want to have a way to call out to describe the sides. So this is a significant point over here. Let us call this PQRS. Let's call this S. Okay? What? Okay, so now let us form equations. What can we write down first? Let's consider the first triangle over here. Okay, right angle. Give me a trigo ratio that you think is applicable to this question, that is relevant. No, which trigo ratio? Tangent? Okay, so we've got tangent, sine, and cosine, right? So you are saying let us use tangent. Okay, let's try tangent 28 degrees equals to H over PS. Okay, now this is tangent. What if we were to use sine? Let's just consider in our minds, if I use sine 28 degrees, is H over PR. Comparing your tangent and your sine, which one do you think is going to be more useful to answer the question to find H? Why tangent? Wait, because we have the value for PQ. Exactly, we have this 380. It is related to our PS. Okay, this is how we are trying to eliminate options that are not that critical. Whereas if you choose to use sine, PR, I don't know what it is, so I will confirm be stuck. Okay, similarly for cosine, 28 degrees, I will have adjacent, which is PS over PR, which I don't know what PR is. I have no information on that, so I'll be stuck. So let us not use this, we will use tangent. But right now, I still have two unknowns, H and PS. Whereas on this side, it is a number. It is simply a number that you can find out from your calculator. So that's one piece of information we have already. What is another equation that I can form?
Tangent 42.
Tangent 42 degrees equals to?
H over SQ.
SQ. Absolutely correct. However, now I have three unknowns in two equations. Everybody knows that three unknowns I cannot solve with two equations. I only can solve two unknowns with two equations. Is there a way to reduce the number of unknowns? What is it? SQ. What is this SQ actually? 380 minus PS. Now you have two equations with two unknowns. And you can solve it. Alright? These are just numbers. I'll leave it to you. It is a simultaneous equation question with two unknowns, H and PS. Solve for them. Once you have PS, you will be able to find SQ because it is 380 minus PS. So that will be how we find the value of H. And part B, find the distance PR. Once you have H, you have an angle, you can find PR. So part B is very easy if you can do part A. Okay? That's all for the homework.